Hello, we are Fast Data Limited, a small consultancy company. My name is Radek, and this is Marta. We really enjoy traveling, and we do it a lot. As a consequence, we stay in various hotels. What we don't like, however, is spending lots of time on booking the hotels that we want. Wouldn't it be great if we were shown a handful of really good recommendations that we can quickly book? The booking site not only would get our money, but also have a very satisfied customer. Win-win situation. The project consists of 3 phases. First, we analyze the data and come up with several recommendation models. Then, we use them inside of a RESTful web service. Finally, we test its fitness for production. Is this your perfect hotel? Or maybe this one? It depends on manufacturers, of course. Let's look at a dataset from a recent competition, where a goal is to predict up to 5 hotel clusters that the customer is going to book. The summary of our research is presented in the form of Spark notebooks. In short, we explored the data and came up with a testing strategy. Then we engineered features and incrementally build and improve the models. We've tried various machine learning techniques: naive Bayes, random forests, and 2 variations of collaborative filtering. Finally, we came up with our best model. It uses the history of user clicks and bookings and tops it up with most popular hotels per destination. To illustrate how good it is, from the top 5 hotel clusters that we recommend out of 100, on average, the actual booked cluster is 50% of time at second and 50% of time at third place. Job's a good one. To make the model actually useful to the business, we built a web service. We initially investigated Spark Job Server with a streaming recommendation engine in mind. However, despite various optimizations, it was not scaling for more than 20 users, even on an 8-node Spark cluster, and the response time was quickly bigger than 1 second, making it unfit for a real business setting. We therefore pivoted to a Play framework app and exported the model from Spark. The web service exposes a RESTful interface, allowing it to be easily integrated into other services, or directly into websites or mobile apps. As it's stateless, it can also scale linearly by adding more nodes and load balancing. For parameters, it takes the model name, a destination ID, and an optional user ID. It returns an ordered recommendation of top 5 hotel clusters. As the saying goes, best things come in small containers. We are therefore packaging the service as Docker image. It provides us with ease of deployment and portability between various cloud platforms. We started the portability evaluation by deploying it to Amazon Web Services via Docker Cloud, and it all worked very well. We also deployed it to Bluemix Container Service, and the response times were actually faster, so we ran the performance test against it. The test consists of randomly choosing 1 million records from a test dataset and feeding it to the web service to make the recommendations. It was implemented and ran with Gatling Stress tool. As we can see on the results page, one instance of the server easily handled 1 million requests in total, with constantly serving 100 requests per second, even though it is running somewhere in the US and we ran it from our laptop in Scotland. 95% of requests completed below 361 milliseconds. Finally, let's see how the service can be used on a simple web page with a handful of examples. There are 2 models to choose from. Mixed model is our best model that we built so far, and a simple collaborative filtering model. We also have a selection of most popular search destination IDs and a selection of user IDs. By clicking this button, we invoke the web service and we get 5 best hotel clusters that are recommended for this particular search destination and for this particular user. To sum up, Sparkommender is an example of a project where we can leverage the power of Apache Spark to make your business thrive. Thanks for your attention, and we hope that you enjoyed this presentation.